All right, this is the first day of Unit 2, Lesson 1. Our topic today is on relations and functions. So first we're going to talk about relations. So we've got just some fill-in-the-blank things here to give you some definitions. So a relation, its easiest definition is a set of ordered pairs. That's it. It's as simple as that. The format can be quite different. So it can be shown in a table. It can be shown as a mapping. It can be shown as a graph. Or it might be expressed as an equation. So all of these things we'll see at least one example of today. The set of x values is called the domain. So all of the possible x values, that list, you call that the domain. And all of the possible y values, we call that the range. So a couple more definitions that we'll be talking about today. A relation with distinct points, like if you can count out how many ordered pairs there are, we consider that to be discrete. So think of it as being countable. If the number of points is countable, it's discrete. If you have connected lines or curves, which means you have an infinite number of points, we would consider that to be a continuous relation. All right, so some vocab words that we're going to be talking about as we go through this lesson today. So now the definition of a function, here's our definition right here. This is a relation in which each element of the domain, so each of the x's, is paired with exactly one element of the range. So those are the y values. So each x value is paired with exactly one y value. You can't have one x value going to two or more y values, then that wouldn't be a function. So just some quick examples here. So we use these little like squiggly brackets, and then we put some ordered pairs. So if we had 0, 1, these are just some sample ordered pairs that would make a function. Okay, so this one's a function. You've got 3 different x values right here. They are each getting paired to one y value. 0 gets paired to 1, -5 gets paired to 2, 6 gets paired to -2. That's an example of a function. Something that's not a function is something like this. So this, see how we have this 6 and this 6. 6 as an x value is getting paired with -1, and then that same 6 is getting paired with +2. That means that this is not a function. You've got one x value that's getting paired with 2 different y values. So that's the main thing that we're going to be looking at on the rest of this page, is just trying to figure out if something is a function, and that's the rule that you need to keep in mind. So kind of a summary right here. This means x values do not repeat. If x values don't repeat, it is a function. If x values do repeat, that means that it's not a function because it wouldn't fit our definition. Visually, if you're not looking at just a set of ordered pairs or a mapping, say you're looking at an equation or a graph, you can see if that function passes the vertical line test. So here's a little quick summary of the vertical line test. It says if something is a function, a vertical line cannot pass through more than one point. So here's an example of a function. Just a nice, easy line, something like that. So when I say a vertical line, I mean literally visualize taking something that's vertical and trying to pass it back and forth through this graph. My pen would only intersect the graph once. One time, one time, one time. That means it passes the vertical line test. That means it's a function. Something that's not a function would be, let's say if I had something circular, if I tried to pass a vertical line through, it's usually going to cross through twice. So say I had like a vertical line that we tried to pass through right here. It's going to cross through my graph right here, and it's going to cross through my graph right here. That means that that is not a function. It is failing the vertical line test. All right, so now that we've got some definitions, some ideas of what it means to be a function, what it means to not be a function, we're going to look at a handful of these and figure out what is and what is not a function. All right, so let's do 2 and 4 on this first page. So if we look at number 2, for domain, we want to just literally list out the possible x values that we have. So we're going to use our little squiggly brackets, write them down. So we have 5, -3, 5, 8. If you're able to pull it off, it's good to put them in numerical order. So -3 is the first one, and then 5. We have another 5, but we don't write it twice because it's already covered. And then 8. And then once you're done, close off your little curly brackets And now let's do the same thing for the range. So the range is all the possible y values. So we have 2, 4, -6, 0. So again, try to get them in numerical order. So the -6 would be first, and then 0, 2, and 4. So those are all of your possible y values. So the next thing we want to figure out is if it's a function, and that's going off of these definitions that we have up here. So remember, this is kind of our big indicator. X values do not repeat if you have a function. And right now we do have this repeating x value. The 5 repeats, so what that means is that no, it is not a function. Okay, so that's one way. When we wrote down all the possibilities, that's a table. The next thing that that's just a list of ordered pairs. The next thing we're going to look at is a table. So here's a table. If we look at number 4, you've got all of the x values listed in a table, all of the y values listed in a table. So they are just listed right there for you to just kind of repeat, and they are in order already. So just writing down this column, these are all of our x values, no repeats. And the range is just all of the y values, no repeats there either. So is it a function? If there are no repeat x values, then yes, it is. So here's 10, 15, 18, 24. None of them repeat. They all go to their own unique y value. So that means that yes, this one is a function. So that's what a table looks like. On the next page, when we wrote mapping up at the top of the first page, 5 and 6, that's what a mapping means. Like you've got this just circle of these different x values, circle of these different y values that we can see. So we are going to, we'll take a look at number 6 right here. So the domain, same thing, they're kind of just written right out here for you. So we have 2, 8, 13, and 17. Those are all the possible x's. And then the y's, we have -4, 0, and 7. So when we talk about a mapping, you're following the arrows. So one ordered pair would be 2, 7. Another one would be 8, 0, 13, -4, and then 17, 7. This situation right here freaks people out because 2 maps to 7 and 17 maps to 7, that's actually okay. That's not going against our rules. We're not allowed to have repeat x's. The rule never says anything about repeat y's. Something like this in number 5, that's a problem. See how there are 2 arrows coming out of the 5. That means the 5 maps to 2 different values. This one wouldn't be a function, but this is actually okay. It's perfectly fine for 2 different x values to map to the same y value. So that means that this is a function. All right, so let's look through a couple of these ones. So these are going to be a little bit more challenging when you have like a little list, like an actual graph of ordered pairs, and all these graphs that we have right here. So this one, the domain, you can list out the x values. So like these 2 ordered pairs have an x coordinate of -3. And then your next one we come across is this one. This has an x coordinate of 0. This one has an x coordinate of 1, 2. And then this one has an x coordinate of 4. So those are all of your x coordinates. Y coordinates, since we want to go in numerical order, we can start from the bottom here. So this one has a y coordinate of -1, 2, 3, 4, 5. Then this is the next lowest. That's at -2. So this is the y coordinate of the ordered pair. This one is at -1. This one has a y value of +1. And then this one up here is 1, 2, 3, 4 for the y coordinate. So all the x's, all the y's. Now this right here, that's a repeat x. These 2 coordinates have the same x value, and that's not allowed if something's going to be a function. So no, this one is not a function because we have a repeat x value over on that left-hand side. For number 8, now we're going to start getting into some kind of interesting domain and ranges because these ones are no longer discrete. Now we are looking at continuous functions, which is one of the definitions we had on the previous page. So this one is a continuous function. It's just a line. You have an infinite number of points, so we can't just list them the way we did here because it's not a finite number. It's not a countable number. So the domain, all the x values, this arrow just keeps on going off to the left. This arrow just keeps on going off to the right. So if we were to continue to graph this, every single x value is going to get covered. So what we write for our domain is that all real values can be covered. So we have this little symbol. It's kind of like a capital R, but it has this like double block on the side. So whenever you see that, that stands for all reals. That means every number will eventually get hit if you keep graphing. The range is all the y's. This arrow will keep going down and keep covering y values. This arrow will keep going up and cover y values. So the range is also all reals. So every x and every y will eventually get hit by this line if we keep on graphing. So with a graph, we check the vertical line test. Kind of pass a line back and forth to see if it's ever going to cross through more than once. And it doesn't, it passes. So that means that this is a function. All right, let's look at a couple more of these down here. Number 9, we've got, this is like our x values stop right here. So none of these x values get covered, but then it keeps on going off to the right. So the x coordinates that get covered are greater than or equal to this point right here has an x coordinate of -1, 2, 3, 4. So everything to the right of -4 will get covered because this arrow just keeps on going, but there's nothing over here in terms of x values. For the range, this arrow goes up, this arrow goes down, every y value gets covered eventually. So that is all reals. Function, vertical line test. If I try to pass through, right here I'm crossing through, I cross through more than once if I try to pass a vertical line. So this is not a function. And one more like this, number 10. There are no arrows on this one, so this is my starting x value. This is my ending x value. So when I'm in between two numbers like that, I write it as a 3-piece inequality. So this x coordinate is -2. And then this x coordinate is 1, 2, 3, 4, 5. So remember, this 3-piece notation means that my x's fall in between -2 and +5. And I can do the same thing with y's. So this is my lowest y coordinate. This is my highest y coordinate. This is a -2. So now this one's for y. And then my highest is 4. So that's how I write the domain and range when they fall in between two values and there aren't any arrows. Is it a function? No, we are definitely failing the vertical line test right here. So this is not a function. Okay, in this last section right here, we have equations, but we don't have graphs. So I'm going to show you guys how we would use Desmos, that Desmos app, to graph what you should be looking at here. So we're going to do a couple of these. So this one, we've got -x² + 3. So Desmos looks like this. And you would, of course, be using your iPad, but I'm using my iPad to record this. So y equals, so we can type in y equals, and then just type the exact equation, -x² + 3. And then if you want to, you can click back on here. You can click this little double arrow to just move the equation over so you can get a better look at this picture. So now that you've got this in front of you, it's basically just like looking at one of these in front of you. You just have it on your device instead of right on the page. Turn, there we go. So my domain, this is gonna keep going, okay? There's no end point. Like it keeps going to the left, keeps going to the right. You can kind of scroll around and look. So for my domain, there are no restrictions on my x coordinates. For my range, if you look right here, and this is a beautiful thing on Desmos, you can just kind of click and see that that highest y value is 3. Okay, so it never goes above 3. So for my range, you would say my y coordinates are everything 3 and lower. So it starts at 3 and then it just goes down from there. Is it a function? It is, yeah. If we tried to check a vertical line test, it's not gonna like overlap itself and go through more than once. So this is a function. Okay, let's look at one more. Let's look at number 14. So I'm gonna press these double arrows again. I'm gonna X out of this line that I put in here and type in another one. So now I'm gonna type this in. I'm gonna type x equals -1. Now once that's there, I can press these little arrows. So this is actually just this vertical line right here. That's all that the equation is this vertical line. So when I'm looking at what x values get hit, this is actually literally the only x value that gets hit by this graph. So for my domain, I'm gonna write x equals -1. That's it. Literally just that one x coordinate is the only thing that gets hit when I graph this. Now for my range, this goes up forever, it goes down forever. You will eventually, if you look at more of that line, you will eventually hit every single y value that you could ever imagine. So that means all reals. A function, this is the ultimate failure of a vertical line test because it is a vertical line. So a vertical line would have an infinite number of points. You have one x value that's getting mapped to an infinite number of y values. So this is definitely not a function. All right, so that's it for lesson 1.